Good day, everyone. Welcome to my lesson today. We shall be treating the topic motion. Motion. And motion in physics simply means movement or a change in position of an object between 2 points. We can look at it in terms of the vertical change in position or the horizontal change in position of a body. Now, generally, there's a fundamental question about motion. And the question is, or the questions are, 1, why do things move? What keeps them moving? And why do they stop? These 3 fundamental questions were reasons behind Isaac Newton's research work on the term motion. He was able to find out that motion is caused by force. And because we just mentioned force, we will take time to define what force is all about before we continue. Force, I take it, is that which produce, I'm talking about force, is that which produce or tends to produce a uniform change in the state of rest of a body. Now, when a system is at rest and you apply force on it to cause that body to change its position or try to change its position, we say that force is in effect. When we go further, we will understand that there are basically two types of force. But since we know that force causes motion, let us go back to the concept of motion and understand that there are 4 types of motion. Remember, in all this, we are trying to answer the question, why do things move? What keeps them moving? And why do they stop? Now, in an attempt to answer this, we need to understand the mode of operation or the different ways in which this force is classified. So at the level we are today, we shall be looking at motion in 4 different ways or types. 1, we shall be looking at translational motion. Translational motion. Translational motion. Translational motion or rectilinear motion. This is the complete or whole movement of a body from one point to the other. We must understand that this translational motion or rectilinear motion does not necessarily have to be on a straight line. But what it means is that a body that is involved in this type of motion must move wholly from one point to the other. For example, your teacher moving from this point to this point performs translational motion. A man traveling by air or by land from a location in Nigeria to another location in Benin, in US, in UK, is performing translational motion, whether by air, by land, or by sea, because wholly that object, that person, changes position with time. The next type of motion we shall be looking at is vibratory or oscillatory motion. Vibratory or oscillatory motion. When we talk about vibratory or oscillatory motion, we are talking about the motion of an object to and fro about a fixed point. The motion of a body to and fro about a fixed point. Example of bodies that perform the bodies that perform vibratory or oscillatory motions are 1, the skin of a talking drum. An African man will understand the typical talking drum. At any time the skin of the drum is piped, it vibrates. That vibration is an example of this type of motion, vibratory or oscillatory, because it vibrates about a fixed point to and fro. Another example of vibratory oscillatory motion is the motion of a loaded test tube floating on water. If you have a test tube half filled with a piece of iron, short piece of irons, and you suspend it on top of water, you will notice that the test tube will be oscillating up and down on top of the water. I did not say a loaded test tube. I said a loaded test tube floating on water. Another example of of vibratory motion is a mass attached to a clamped plank, in this case a ruler. If you attach a mass to one end of a ruler and allow it begins to dangle or oscillate up and down, while the fixed point is the point that is clamped. The third type of motion we shall be looking at is the random motion. The random motion is also known as the zigzag motion or Brownian motion. When we talk about random motion, we are talking about a form of movement that is directionless. Popular amongst the examples is the movement of a man or a woman in a marketplace. When you move in a marketplace, you may not necessarily have a specific path to follow. Another example is the motion of smoke, whether from the exhaust, whether from the chimney, whether from a local fire setting, wherever it is, or breeze that is blowing. All of them move, the particles move in different directions. That was the reason Robert Hooke, in his first experiment, he was able to discover that when he dropped pollen grains inside a test tube of clean water, he observed that the motion of the pollen grain was not following a definite pattern. They were moving in different directions. And he said, Eureka, I have found it. And that motion was named after him in honor of his research work. And it was called Brownian motion. So another name for random motion is zigzag motion or Brownian motion. The fourth, but not the least, form of motion is the rotational motion. Rotational motion. Another name in some textbooks, you will observe that it is always used interchangeably with circulatory motion. Now, the difference between rotational motion and vibratory motion is that in rotational motion, it is the motion of a body about a fixed axis. Rotational, the motion of a body of an object about a fixed axis. A vehicle running along a curved path is performing rotational or circular motion. Remember, the axis does not move. The rotation of the earth about its axis is an example of rotational motion. The earth moving around its axis, in this case, around the sun. All these motions, all these types of motion are the simplest popular ways in which objects move. Now, in our next class, we shall be looking out to other aspects of this topic. We begin to look at simple questions we can answer, simple explanatory mathematical questions that will give us deeper understanding of this topic. If there are questions, you will let me have them on mine. If there are questions, drop your questions while I look forward to sending correct answers. Remember, it is Teacher Okai that is in charge of this class, and you are always welcome. As you like, you also share in this video. Thank you for today.